Okay, let's go over the squiggly line. I think you will come to love this method, but it does take a little bit of practice to get used to it. This is your first homework problem that really you had to use the squiggly line. And the reason is, if you FOILed this out, you'd have x squared minus x minus 6, which of course, here's the key. It is definitely a quadratic. It is not linear, so we must use the squiggly line method. First step, set equal to 0. Well, that's already been done to us for us here. It's already set equal to 0. Second step, factor. That's already been done for us. So this problem's kind of ready, set, and waiting. So we need to really do the third step, which is to put the solutions on the number line. Solutions on a number line. And when I say number line, it really is not going to have a lot of numbers on it. You just draw a line, you say, okay, at -2 and at +3, I have some solutions. That's because each factor, if you set it equal to 0, that causes a -2, and x equals 3 is a +3. Okay, fourth step. Well, I always like to label the points. So label the points open or closed. And so if I do that, like let's see, this is a parenthesis, I mean it has a less than, so there's no equal sign, so both of these points are going to be open points there. So you have to think of this line as above the line is positive, below the line is negative, and on the line is equal to. Since there's no equal to right there, this x values can never be equal to 0. They must be smaller than 0 is what it says. So the fifth step is to test a point, or test an x value. I usually test a very large x value, and when I say large x value, I mean at least larger than the largest x value that's on this line, which is 3. So something larger than 3. So I'm going to test a value like, let's plug in 4. So 4 plus 2 is 6, that's positive. 4 minus 3 is 1, which is positive. What happens when I multiply a positive number times a positive number? Well, I get a positive number. And so my graph, when I start graphing this, it's going to start up here. Now I don't know what it looks like, that's why I do a squiggle, but it starts here above the line, because when I plugged in some value bigger than 3, like 4, if I plugged in 5 or 6 or 7 or 8 or 9 or 10, all of those answers would have been positive. That's all I care about, is that in this section or this interval of the graph, it's positive. Now, you look at the exponents of the factors. Both of the exponents are 1, which means it's going to go through. They're odd. So, and in most cases in the homework, you're going to go right through. Now, it's got to touch both -2 and 3 in the x-axis. It has to make its way back up here somehow. And it's going to go through, and that's your graph. So, the question says, where are these values less than 0, or negative, in other words? So you can see on the graph, all these values are less than 0. So what interval are we talking about here? We're talking about the interval between -2 and 3, are all those x values, not including 3, not including -2. And that's my solution. So the last step is identify the solution interval, or intervals. Identify, you really have to draw the squiggly line somewhere in there. Draw the squiggle, but identify the solution interval. Okay, next one I won't have to write down all of the terms, but let's go to the next homework problem, see if we can do it. So this one, we've got our first 2 steps done for us. Let's go ahead and draw the squiggle. We've got x equals 0 as a solution that comes from that x. And then 2x plus 7, if I set that equal to 0, 2x plus 7 equals 0. So 2x equals -7. And x equals -7/2. And so I have -7/2 and 0. And let's see, so it has an equal sign in it, so I know at the point I'm going to be closed circle. I need to test some value bigger than 0. Let's test 1. So if I do the first there, that's 1, which is positive. I really just need to put positive there. Times plug 1 in here. 2 times 1 plus 7 is 9, which is positive. What happens when I multiply positive times a positive? I get a positive, so my graph is going to start up here. It's going to come to that point, and you can see both of these exponents of the factors are 1, which means it's going to go through. Got to come and touch that point. It's going to go through, and that's my squiggly line. Now in this case, we're asked a different question. It says, when is this greater than 0? When are these values above the line is what it's saying. Well, right there and right there. And you'll also notice that it has an equal sign that right there, so it also includes the point at -7/2 and includes the point at 0. So I really got 2 sections of the graph here that I need. So if I'm going to write my answer, I'm going to say something like, okay, well, this interval is from less than or equal to -7/2. So with interval notation, I might say something like -infinity, comma, -7/2. And you can say union or comma would be fine here, with from 0 to infinity. So there's really 2 sections of this graph. The values that won't work, the only values that won't work are between -7/2 and 0. If I were to plug in something like -1, -1 times -2 plus 7, -1 times a positive number is negative. A negative number is not bigger than or equal to 0. If we plugged in any number in here, it's not going to work. It's not going to make the inequality true. But any number smaller than or equal to -7/2 or any number 0 or bigger is going to make this inequality true. I think you may be starting to get the idea here. By the way, I think this is supposed to be 3x here. I think I didn't type in the whole problem there. So if I factor this one, let's see, x and x. Factors of 18 would be 6 and 3, negative and positive. I've got x equals 6 would be a solution, and x equals -3 would be a solution. So I draw my line, and -3 and 6, put my points, and less than 0. Well, let's plug in some number. Let's draw a squiggle. I like to draw the closed circles first here. We have closed circles. So definitely closed because of the equal sign. Plug some value in bigger than 6. So 7. 7 minus 1 is positive. 7 plus 3 is positive. What happens when you multiply a positive times a positive? You get a positive. So I start above the line. I get to the point. As in most of these problems, it's going to go right through those points. You've got the squiggle down, and you've got, let's see, less than. So when it's less than or equal to, I want the portion below the line, the negative portion that would be from here to here, not including, or actually I am including those points on the end because it does have an equal sign there. So my solution interval would be from -3 to 6, and that's my answer. So the squiggly line actually gives us the answer, the solution interval that that it's asking for. I'm going to let that you solve that one, and I'm going to go to a little harder problem. I'm going to try this one. So let's try this one and see if we can get it. There's just a little tweak here I want to make sure you get. It's already factored. There's a factor up there, and there's a factor down here. And so you get x equals -1 from this factor. You get x equals 3 from this factor. So on my line, I've got -1, I've got 3. Now this is where the little trick comes in here. You got to be careful. Normally, when you see this equation, you see the equal sign, you'd go close circle here and close circle here. However, I'm going to put an open circle there. And the reason is, remember, what do we have? What do you know about the denominator? The denominator cannot be equal to 0. And so you have an open circle right there. So what you're going to do then, so we have open and close, so that's okay. That comes from the denominator. You just have to be extra careful when there's a division involved here. So I'm going to plug in some value bigger than 3. Let's say 5. 5 minus 3 is positive. 5 plus 1 is positive. What's a positive divided by a positive is positive. So I'm going to start above the line, or positive. Both of these are to the first power. So it's going to go through, get to here, come on up. And what is my question really asking for here? Greater than or equal to 0. That would be above the line or on the line, and above the line over here. So I have two intervals that the solution would be by. So this one would be the interval from negative infinity to negative 1, union with from 3 bracket there to infinity. I'm also okay with just putting a comma in between the two, but that would be our solution intervals there. We have this whole area, we just don't have this area in between here. And so that's how you handle denominators. And so I'm going to stop the screencast here, let you finish the rest of your homework. I think you should be able to do it. Hopefully that was enough to kind of spur you along on this homework. I know we had a limited class time, so hopefully going over some of those homework problems helped you. I am finished. Thank you.